Hi, my name's Nairn Spence. I'm a PhD student at the University of Edinburgh studying in the School of Engineering's Institute of Energy Systems, and I am up here in Orkney near the tidal turbine run by Orbital, getting ready to deploy some ADCPs to measure wake data to get a better idea of how to design tidal energy farms in the future. We're going to be using Sonardyne's Origin 600 ADCPs deployed in Sonardyne's lander bed frames, and they have dual redundant acoustic releases which will help us for recovering them at the end and allow us to acoustically position the bed frames accurately for both heading and their absolute position.
Working with Edinburgh Uni and Nairn's team for a couple of years now to model the wakes in the site. So model the site and then model the energy extraction process. So putting turbines in the site to see the wakes that are generated. And the models there's a number of different ways of modelling it and they all give slightly different answers. So it's time that we need to actually measure it and work out what the real answer is so we can continue to develop the models. So we went for a turnkey solution with Sonardyne's latest ADCP. And the goal was we needed quite a high positional and heading accuracy of the instruments. So we needed a system that was going to be quite slick to deploy. And the feature of the Sonardyne kit that was very useful was having real-time communication with the ADCP as it was going down and as it was landing in the seabed, reporting its position and heading and tilt. Because we need it to be basically completely level. We need a very precise heading on the installation and we need a very accurate position on the installation. So the Sonardyne kit allowed us to do all that in quite a slick manner, having real-time communication with the ADCPs throughout. So it's certainly the most accurate deployment we've ever done in terms of location, heading and tilt.
So for this particular deployment we needed the navigational and sort of positional integration that you get from this kit. We're looking for a feature in the water column that's only about 20 meters wide from a turbine that's sort of moving in its position throughout the tide. So it's a very small feature to be measuring in a 50-meter depth of water. So being able to really accurately position where we put the ADCPs was essential.
We're using a Sonardyne Gyro USBL to position the transponders that you see here on the frame and make sure that we accurately put them down on the seabed and orientate the frame correctly before we release it and leave it to measure the water flow. We've got 3 different acoustic positioning devices, and it's quite nice to actually compare the orientation of the acoustic transponders with the magnetic heading sensor on board the ADCP.
The lander itself, so in addition to the real-time communication, it's quite a low-profile frame, quite lander, so it should remain quite steady. We're able to add a bit extra ballast because the current speeds are so fast at this site. It's one of the fastest sites in the world. So it's heavy, it's low profile, and we know that we've landed it flat because that got reported in real time, so that gives us the best chance of getting good data.